In order to answer a problem, we first need to understand it. And one of the ways of understanding a problem is to draw a diagram. In this case, it would be a graph. We're given a function and we're also given a tangent to that function. So if I was to draw this, it might give us more of an understanding than if I'm just looking at it abstractly here through the algebra. So what I can do is I could draw this function here using my knowledge of graphing. But in this case, I think what I'm going to do is I'm going to use a graphing package. So I'm going to look at graphing functions. My search term would be something like graphing functions, and Desmos is a pretty good free graphing package. You could use GeoGebra as well. And what I would do then is I would enter these functions. So y equals 9 minus 4x minus, and note I'm putting the 8 over x in brackets. So here is my first reciprocal function, which makes sense given my knowledge of graphs. And I'm also going to enter the one that I need to show, the tangent. And this then, here's the tangent in the blue line, and we've got the function with the red line, and it says it crosses at the point x equals 2, or the tangent touches the curve at this point here. So our gradient of the tangent, remember, will be the same as the gradient of the curve at this point. So this gives me a little bit more of an understanding. Going back to the abstract part of this, we know that at this point here, we have x equals 2. So we can work out what y would be at the point where the tangent crosses. So y, if I substitute x into this function here, I would get 9 minus 4 times 2 minus 8 over 2, which equals minus 3. That's 9 minus 8 minus 4, which equals minus 3. So I know that at the point P is 2 minus 3. And again, looking at my graph, I've got my point P here, which is minus 2. Sorry, 2 minus 3, I should say. I've got my function in red, and I've got my tangent here, which is what I'm going to show. I also know that the gradient, as I say, at the point P is going to be the same for the tangent and the curve. And I know from my knowledge of derivatives that I can find the gradient function from this original function here. Dy by dx would equal my gradient function. Now, in order for me to differentiate this function, I'm going to have to rearrange it, because the minus 8 over x doesn't necessarily make it easy, especially if we're just using simple differentiation here and not using, say, the chain rule or something similar. So let's rearrange this. I'm going to have 9 minus 4x, and this will equal 8x to the minus 1 using my knowledge of indices. If you're confused about this, remember 8 over x can also be represented as minus 1 multiplied by 8 multiplied by 1 over x. We know that 1 over x is x to the minus 1, so that would be the same as minus 1 times 8 times x to the minus 1, which would be the same as minus 8x to the minus 1. Now I've got my function in this form here, I can differentiate it. So it would dy by dx would be, well, that 9 would disappear, and I'd have minus 4 minus, and I'd have minus 1 times minus 8, which is actually a plus 8, and it would be x to the minus 2. Again, if you're confused by that, let's take that aside, and we'd have dy by dx of 8x to the minus 1. What I want to do is I want to multiply the power, remember, by the coefficient. So I'd have minus 1 multiplied by minus 8. That would be my new coefficient of dy by dx, if this was y. And I would then take away 1 from the power. So that will be x, and minus 1 is minus 2. So that will be the same as 8 minus 1 times minus 8, x to the minus 2. So here is my gradient function. So I know that anywhere along this red line here, the gradient is this. So for example, at, let's say, here where x is something like, say, a half, not quite sure, I could substitute in a half here and I'd get a value of the gradient here. Here, x is 2. So if I substitute in my value of x here of 2, I would get what the gradient is at this point. And that will help us to find the gradient of the tangent. So let's do that. So we would get minus 4 plus 8 times 2 to the minus 2, which would be minus 4 plus 8 times 1 over 2 squared, which is the same as minus 4 plus 8 times 1 over a quarter. 8 times 1 over a quarter is 2. So I'd end up with minus 4 plus 2, which would be minus 2. So my gradient at this point here, P, my gradient equals minus 2. Well, that helps us a lot because we know that this tangent is in the form of y equals mx plus c. And we know that then at this point, y equals minus 3. We know that m, our gradient, is minus 2. And we know that x is 2. So we can work out what c is. So we'd end up with minus 3 equals minus 4 plus c. So if I add 4 to both sides, I get c equals 1. Therefore, my gradient of the tangent would be y equals, well, m we said was minus 2 and c is 1, which if I rearrange would be 1 minus 2x. And here you can see that this is the same as what we were given. Y equals 1 minus 2x, y equals 1 minus 2x. So we were asked to show that the equation of the tangent is 1 minus 2x, and that's what we've done here. Now we need to find the equation of the normal. And the normal, if you remember, is the line that crosses at right angles to the tangent. So it is the line that would cross at right angles to the tangent at this point. So our gradient here is still the same for the tangent, but for the normal, remember our gradient of the normal and the gradient of the tangent, when I multiply them together, I get minus 1. So I can say that my gradient of the normal is minus 1 over my gradient of the tangent, which was minus 2. So my gradient of the normal would be a half. And let's just go back to our lines here, to our graph. A gradient of minus 2 will go downhill, which is what this is. And a gradient of a half will go uphill and will be less steep. And that's what the normal looks like as well. So I know it passes through the point 2, 3. It's got a gradient of a half. So again, I can substitute in y, the x and the m, because y equals mx plus c for a straight line graph. So I'd get minus 3, which is my value of y. But this time it's a half multiplied by x, which is 2. And that will give us my value of c. So I'll end up with minus 3 equals 1 plus c. If I take away 1 from both sides, I end up with minus 4 equals c. So my gradient of the normal would be y equals m of a half x plus c, so minus 4. And that there is my gradient of the normal. So we've got the gradient of the normal, and here we've got our gradient of the tangent. For the next part of this, we've got to find the area of a triangle. So it says the tangent meets the x-axis at A, so this is the tangent, so this will be my point A, and the normal meets the x-axis at B, and I need to find this triangle APB. So this triangle here, we know that this is a right angle. So there's a number of ways of working this out. We could find this length of this line, this length of this line, multiply the two together and halve them because it's half times base of this perpendicular here. Another way that we could use is we could work out the perpendicular height here and multiply it by this line here, which then will become our base, and then multiply by a half in order to find the area. And this second method here is, I think, slightly more efficient because there's less to work out. We already know what this distance here, this perpendicular here is, what this line length here is, because all it is this y distance here, which is 3. So all we need to work out then is our length of the line AB. And in order to do that, we would need our x-coordinate of A, where it cuts the axis here. So let's just work that out quickly. It would be, for this one, equation is y equals 1 minus 2x. So here y equals 0. So we'd have 0 equals 1 minus 2x. So therefore 2x equals 1, so x equals a half. So at this point here we've got a half, 0, and at this point here we would have 0 equals a half, x minus 4. We're taking this gradient of the normal, right, not the gradient of the normal, the equation of the normal. Hope you was spotting that deliberate mistake there. Equation of the, and we would have 4 equals a half x, so therefore x equals 8. If you remember, I drew this line in here. I didn't use the graphing package, so that's why it's slightly off, or looks slightly off. This is not to scale anymore. Okay, so I can then work out what my line AB is. It would simply be 7.5. So it would be, the triangle area would be a half multiplied by 7.5 multiplied by this height here, which is 3. And that would be 15 over 2, which is 7.5 multiplied by 3 over 2. And that would be 15 multiplied by 3, which is 45. 2 times 2, which is 4, which would give me 11.25. And that's my area of the triangle.